Hello and welcome. I'm Daniel Beezer. I'm a senior analyst with Analysis Mason, leading edge and media platforms practice. And in this session, we're going to look at a case study. And the case study is in the area of warehouse automation and autonomous mobile robots. And we're just going to look how 5G and edge computing can create some real value in that area. And to do that, I have two panelists with me. I'll get them to introduce myself. We start off with Renu.
Hi, everyone. I'm Renu Navle. I'm Vice President and General Manager of the Edge Platforms Division from Intel Corporation. And I'm delighted to be with you all here today as part of this case study.
And Walter, if you could introduce yourself.
Yes, I am Walter Buga. I am founder and CEO of Arenda, which is the startup. I'm going to give you more information about what Arenda is doing and the product. My background is telecom. I spent years in the labs of AT&T and Lucent, and I for a model company before Aringa. We did software updates over there for automotive, and we were happy to be acquired by Intel. So we work for Intel from 2016, and after we formed a new company, and we have this great partnership with Intel. But I will talk more about the Arenda during the questions.
Fantastic. So this is a case study session. So we're going to start off the session with some slides. Renu will present some slides for 15 minutes, and then we'll go into a Q&A. To my whole audience, do put some questions in the box. You can do it during the presentation, and we'll follow up with those once the presentation is finished. Thanks. So I'll hand it over to Renu now. Thanks very much.
Thank you so much, Daniel. And as Daniel just mentioned, we're going to talk about how we are enabling autonomous mobile robots, and you'll frequently hear me refer to it as AMR, how we're enabling AMR with 5G, in particular private 5G, as well as edge computing. So on the next slide, let me first talk to you about how private 5G networks is becoming increasingly popular, especially with enterprises. First of all, in the recent days or months, the cost to own spectrum for private usages has come down drastically. These are due to regulatory changes. It's in favor of the enterprises. So it's allowing them to own a slice or a piece of the spectrum. And earlier, enterprises who were either cost-bound, especially the small and medium enterprises who could not afford public spectrum, they have now a choice to look beyond wired and Wi-Fi. And of course, with regulatory policies, there's a lot of geodiversity, but in general, overall, the cost of spectrum has come down. Secondly, enterprises are excited about the flexibility it gives them in owning and managing the spectrum versus, completely being dependent on another provider to control this aspect of this wireless network within their enterprise. And then the other thing that, enterprises have been looking at is they have a lot of infrastructure with wired and Wi-Fi. So with private 5G, it provides a lot of the reliability that the enterprises enjoy with wired network, but at the same time, it's addressing a lot of the challenges or problems we've traditionally faced with Wi-Fi around things like dead spots, interference, or just coverage overall. So private 5G kind of offers this very highly performant and reliable and secure network as an alternative to wired and Wi-Fi. But at the same time, we know that the infrastructure around Wi-Fi and wired is so significant that anything that we do with private 5G needs to coexist with Wi-Fi and wired, which is really where this whole notion of multi-access edge computing comes into play, or MEC, because it really needs to take into account that, hey, connectivity needs to support all of these different access technologies or access methodologies across Wi-Fi, wired, as well as 4G, 5G, both public as well as private wireless. But in this case, in our presentation, I'm going to talk more about private 5G or private wireless. Now, on the next slide, I mean, if we look at what is really driving this popularity of private 5G, in addition to lowered spectrum costs and higher performant, reliable, secure mobility, it's really the Industry 4.0. So a number of the use cases from Industry 4.0 around smart manufacturing, logistics, warehouse automation, energies and utilities, smart grids, industrial manufacturing, defect detection, all of this represents more than 60% of our use cases for private 5G. Now, on the next slide, we dive deeper into, okay, great, if 60% of the use cases are from, in manufacturing or industrial automation or warehouse automation, what is the opportunity around this? And as we can see, based on some of our analysts' research, the warehouse automation market is around 27 billion by 2025. And by 2025, there will be more than 4 million robots operating in about 50,000 automated distribution warehouses. So huge opportunity in our industry ecosystem for AMR or autonomous mobile robots, the automation of these robots or orchestration and management of these robots, and the value that this can result in for our enterprises in industrial manufacturing, smart grids, energy utilities, and other types of vertical industry. Now, on the next slide, I'm going to talk a little bit more about, what does this mean in terms of, AMR on a automated or warehouse automated factory floor to edge computing to the cloud. Is it all going to be concentrated on one side, or is it going to be distributed? The bottom line here is our belief is that it's going to be highly distributed. It's going to be distributed computing for the AMRs. It's being driven by efficiencies, around the low latencies that's required and the higher performance that's required. And all of this can be really powered by 5G. There's a very nice cycle where, edge computing is becoming more and more available, more and more popular. And this is driving down the costs of AMR because, compute is more available closer to the source of the data being generated from the AMRs. And at the same time, even the cost of AMRs are becoming more and more affordable with warehouses planning to deploy hundreds of these AMRs. But then there's a need to deploy them at scale, and hence a need to manage some of the tasks or orchestrate some of the tasks in a very centralized manner. But it does not have to go to the cloud for every task or every operation. There's a nice medium where some tasks can be located on the AMR, some can be offloaded to the edge server, which is on-premise edge server or edge cloud. And then in certain cases, as you can see from this distribution of functions, certain cases it can go to the data center or the cloud. And our vision is that, in order for us to enable this compute and AI functions, in the AMRs, they really need to be based on latency and other requirements. And then there's a logical division of these workloads across these different locations that can drive the best efficiencies as well as the best business value for our enterprises. Now, on the next slide, let me talk a little bit more about what is the Intel offering? I mean, Intel is a silicon vendor or a chip company. What are we doing with autonomous mobile robots and in working with R&I? First, let me start off with, what are we doing from a technology and assets perspective to enable autonomous mobile robot use cases? So as I mentioned, Intel, first and foremost, is a silicon company, and we have a pretty diverse portfolio of CPUs and accelerators, including GPUs and NICs that can enable, our the offerings all the way from, the device to the cloud. Now, on top of all of this diverse silicon offering or silicon portfolio, we actually have significant amount of software offerings as well that is used in order to enable these use cases with the autonomous mobile robots. Let me touch on a few of these first. From a software perspective, we really have three key offerings that are actually used in these AMR use cases. The first is called Edge Insights for AMR. And this is our optimized software stack in the AMR platforms that has various building blocks such as SLAM, which is really simultaneous localization and mapping, which is used again to really enable and control the autonomous mobile robots, the navigation, depth sensing, and in addition to this, we offer various performance optimization that is exposing or enabling the underlying Intel silicon that is offered as part of the software product as well. And what this does is it's really enabling our AMR vendors and other solution providers, and it helps to accelerate their time to market and also reduce their development costs and development time. The second software offering that I'd like to touch on is OpenVINO, which is our toolkit with AI, computer vision, deep learning inferencing. What this does is it accelerates vision inferencing for the images that get captured from the cameras. So these cameras may be on our robots that, or even independently, that then get used by the robots to do any kind of obstacle detection or environmental sensing that's very critical for the AMR navigation on the factory floors, but also to make sure that it very safely operates and coexists with humans on factory floors. And last but not least is our Intel Smart Edge offering, which is an edge native, which means it's taken a number of the cloud technologies or cloud native technologies and optimized it for the edge. So it's our edge native software infrastructure that is used to manage and deploy the AMR applications as well as the network workloads such as the 5G CNFs. There are some other edge software offerings as well, like Edge Insights for industrial, Edge Controls for industrial from Intel, as well as the Intel FlexRAM reference software for layer 1, as well as Open Visual Cloud. But they are currently not used in this blueprint that we have developed for AMR along with R&I. Now, on the next slide, let me dive a little bit deeper into the Smart Edge experience kits. So when we talk about experience kits, what we're really referring to is that it pulls together, pre-integrated, pre-validated, building blocks or modules. First of all, we carefully select which modules we need to have as part of each experience kit. The second is they're highly performance optimized on our Intel silicon. And then the last but not least, they're integrated with various tools, Helm charts, Ansible scripts, and others to make it a very easy to use experience for our partners as well as various providers. We have different types of experience kits. There's one that is very specifically focused on private wireless, so integrates RAN and core. SASE, which is Secure Access Device Edge, which integrates again, capabilities that are critical for SASE, like our firewall or SD-WAN. And then a broader offering, which we call the Developer Experience Kit, which is really meant to enable developer innovation on our Smart Edge technologies. Now, all of this experience kit capabilities, they are not only location and use case optimized, but they're really geared towards giving our partners and our developers the best experience, making it easy to use using many of our cloud native modern tools. And then last but not least, making sure that the economics work with accelerated time to market and lower development costs for our partners. Now, in the blueprint that we have with R&I on the next slide, we really worked with our Smart Edge Experience Kit to integrate with the R&I's Harmony solution. Now, one of the primary pain points that the industry has is we have a number of we have a very diverse set of vendors for AMRs, which means we've really lacked an off-the-shelf solution that can automate or orchestrate across diverse AMR vendors. And that's really where this Harmony, our Harmony solution from R&I comes in, which offers interoperability across very diverse AMR products. It helps to orchestrate and manage the AMR workloads. And then last but not least, it also enables very easy traffic management and navigation such that the AMRs can operate very safely and very safely coexist with human workers on automated warehouses or factory floors. And the key value proposition of Smart Edge is really that it served as that underlying edge compute infrastructure such that not only could it provided the compute for diverse functions like traffic management or fleet orchestration, but it really enabled the seamless connectivity between Harmony Edge solution as well as the AMR devices. And then, not only does it expose the optimizations on IA, but it's also integrating our Edge Insights for AMR software, which provides the simultaneous localization and mapping, navigation and depth sensing, and then also our OpenVINO optimizations for vision, AI vision and deep learning inferencing that supports the AMR navigation and traffic mapping. Now, on the next slide, what I want to leave you all with is that while we did this case study and with R&I for AMR, we really want to make sure that we are leveraging all of these learnings in the form of experience kits from the that we have in order to unleash developer innovation. So there's numerous use case specific reference implementations, market ready solutions, RRKs or RFP ready kits, all of which is provided in order to really accelerate innovation within our developer and industry ecosystem. And then finally, application vendors are really key to the deployment of these services. And so we have worked to build an extensive ecosystem of ISVs that provide vertical specific applications and capabilities that would be of great interest in any AMR supported use cases. So with that, I'll hand back to you, Daniel, for Q&A.
Great. Well, thanks very much, Manu. That was a fascinating overview of Intel's capabilities in this area, and also the particularly interesting for me, coming from the sort of network world, of the value of 5G over Wi-Fi and Wi-Fi and other fixed line alternatives. We actually have a question from the audience, which is great. You took my request for questions literally, which is very good. So the question we have is, I think this might be a question for Walter actually, which programming language and microcontrollers are used for building this automated warehouse?
It's a difficult question. Well, Harmony product is a number of microservices. So we use different programming languages, depends where they are. They could be different on the edge, they could be different on embedded, AMR, and different the cloud. So we are using a number of different technologies regarding the software development, and we use a number of different hardware, from Intel, smart cameras to microprocessor on the edge, Exxon, and other processors. So it's a really set of different tools, put this way.
That's great. And actually, I think I might stay with you there, Walter, for the first Q&A question, which again related to Harmony. Well, we can see that AMR and related applications are a big focus of the Harmony solution, but could you shed some light on the challenges, the pain points that you're looking to address here with Harmony?
Well, the point is like, about 80% of warehouses are not automated. And, the operators are not really savvy on technology. They are more like operators. So they lack expertise to implement. And the solutions are like a silo. solutions. So, it's really hard to implement effective system with good ROI. And many of those vendors, they have their own navigation, they have different user interfaces. So there's a lot of pain points, plus the labor shortage as well. And also on-time delivery, which is really pushed by e-commerce people.
Yes, and perhaps let's go to Renu now for a question there. This is a really high-level question, but I'd love to hear your view and Intel's view on this. How do you see 5G and edge computing transforming this particular, the warehouse logistics industry as a whole, beyond actually this particular instance of AMRs? That's a question for Renu.
Yeah, sure, Daniel. I think beyond AMR, where we see the biggest use cases, within this industry vertical as a whole, are around smart manufacturing. There's a huge amount of business value, our enterprises see with things like automated defect detection being one of them. There's also, ports and logistics. There's oil and mining, oil fields and mining. All of these are kind of seeing a tremendous need for, computing that can very quickly deliver business value because of lower latency, better automation, that is, better automation from, the insights that they derive from a number of the AI and computer vision type of workloads or capabilities. So it's really around, smart manufacturing, warehouse automation, energy utilities, smart grids, ports and logistics, oil and natural gas mining. All of those are seeing a tremendous need for edge computing, and coupled with 5G, they're able to see a lot of benefit very quickly from a business value perspective.
Right. We've got another question through from the audience, which is: does the Harmony solution provide an integration of AMR fleets with the manufacturer's MES or ERP solutions, which could, say, create a pipeline of automation for the operations rather? Yeah, that's one for you, Walter.
Well, I'm sorry, could you repeat the question, please?
Sorry, yes. It's: does the Harmony solution provide an integration of AMR fleets with a manufacturer's MES or ERP solution, which could, say, create a pipeline of automation for the operations?
Yeah, the answer is yes. Not only AMRs, but also the forklifts and other robotic solutions. And of course, we are connected to IT system like WMS, ERPs. And so we really look on the workflow, and we optimize the workflow for the operation of the logistics center using multiple technologies like artificial intelligence, machine learning, deep algorithms running actually on the AMR itself, and also on the edge computers and cloud.
Great. And just another one here. Could we go, actually, it's going back to actually what we were talking about earlier, but another question is, what's actually unique in the Harmony solution for solving the pain points actually mentioned during Renu's slideshow? Like, for example, I think she was mentioning the large number of siloed of different solutions that are out there that need integrating. And so could you speak to that?
You asked me, right?
Yeah, sorry, that's Walter.
So number one is interoperability. Yeah. And interoperability is critical for managing those heterogeneous fleet of robots. Like I mentioned, AMR, forklifts, robotic cars, you require it in logistics centers. And today we have siloed solutions which involve multiple user interfaces, like I said, created by over 100 AMRs vendors. In most cases, all using their own mapping and navigation software. And this silo slow down integration, increase customer development and maintenance costs. In the end, these silos don't work, and they don't scale, and then they cannot produce an attractive ROI. And so Harmony objective is to eliminate these silos, enable flexible solution for end customers and operators to optimize the business processes, resulting in attractive ROI. If you see on this slide, which Renu saw, we have implemented VDA 50/50 standards for interoperability, but we have also other ones as well. So So the Harmony key orchestration features are real-time task planning, like I said, fleet management, 5G, edge computing that are underlying technology that enable those new possibilities where low latency, high throughput are the game changers. And so our support for AI workloads and computer vision, such as Intel Open API, OpenVINO, enables real-time orchestration of the logistics centers. I mean, this is the key.
That's great. Thanks very much. Let's go to back to Renu now. Now it's interesting to see how R&D and Intel came together to produce this commercially viable solution for logistics and AMRs. And Renu, can you talk to us and pick out some of the technology offerings from Intel that actually helped with this, that were significant within this collaboration together?
Sure. So interestingly, as externally as Intel and R&D kind of came together, even internally within Intel, we had disparate workloads or technologies coming together. On the one side, we had, of course, our multi-access edge computing software, which is Smart Edge, which is really, focused on onboarding and orchestration of, various, microservices or solution capabilities. It takes advantage of features like SRIOV, the container network interface, InfluxDB, various types of dashboard or visualization tools. All of this is part of our Smart Edge experience kit. But at the same time, it also helped to onboard, 5G CNFs or, container network functions like RAN and core that are critical from a private 5G network or in order for the private 5G wireless network to function. And similarly, it integrated with other capabilities. So in addition to the R&I's eHarmony solution, it also helped to integrate or onboard the Edge Insights software for, AMR, which comes from Intel. But what this did is it helped to, again, optimize on our underlying silicon, but at the same time, offer building blocks or optimizations that our vendors and providers can use around things like simultaneous localization and mapping, navigation of the AMR, depth sensing, and these kind of capabilities that would be critical for an AMR to function. So again, we're talking very disparate technologies or functions coming together in order to really enable this AMR use case. And then at the underlying technology of it all is one of our flagship software products, which is OpenVINO, which really uses AI or computer vision analytics. So it's really looking at images gathered from various cameras, analyzing that, deriving insights from that, and using those insights to then guide the navigation or responses that we would need to have the AMRs provide in order to function properly on a warehouse or factory floor. So numerous disparate technologies coming even within from the Intel offering that then works together with R&I's Harmony solution.
That's great. And we've got another question. This is great, all these questions coming through. I think this one's for you, Renu. It says, in Harmony for AMRs and robots, are you expecting much value to come from URL, LC, and TSN based on three? So,
Daniel, can I add something to Renu?
Oh, yeah, of course. Leap in there.
Yeah, I mean, again, I can talk about this for hours. The key is also that majority of R&I employees were part of Intel after the acquisition of my previous company, Arenga, in 2016. And I think the most significant result of working with Intel is access to Intel technologies, team, and support finding the right markets. And I feel the greatest asset we leverage is Intel innovative vision for distributed edge computing, AI, and computer vision. And Renu mentioned that. And trust me, we are taking a full advantage of this. As example, the Intel Edge Insights stack greatly simplifies and accelerates the deployment of the Harmony application running on ROS2 based AMRs. The Intel Smart Edge unified the deployment of Harmony Edge services across multiple environments like on-prem, edge, and cloud. And our solution also leverage hardware products like I mentioned. such as Xenon processor, Intel processor for AMRs, reverse cameras, and other technologies. With all above, Intel technology allows us to focus and accelerate our AMR orchestration solution instead of wasting our cycles and investor dollars on underlying technology. So this relationship has allowed us to build on the top of the commercial grade quality software and hardware. And a great example, I always say this, like 1 + 1 = 10, where Intel has accelerated the digital transformation of logistic operations.
That's great. I think that's really great. I think we see if we can try and get this question in. Renu, I don't know if you can answer this question. I think it's aimed for you. I'm certainly asking you to answer, but in a few minutes, in 3 minutes. Just to remind you what the question was, how much value are you expecting to come from URL, LC, and TSN, which is based on 3GPP Rail 17? To do accurate, so shall I finish on the question? To do accurate and reliable localization, you need more than 5G, such as video recognition, etc., etc., etc. Any views from you, Renu, on solving the horizons of solving this problem? What is the critical market opportunity near term, long term? I think that's a good question.
Sure. It completely depends on the the customer's use cases, and more particularly their URLLC's ultra reliable low latency, their URLLC requirements, like, hey, what is the millisecond or the microsecond requirements they have in order to control the robots. Same thing with things like time sensitive networking or TSN for industrial use cases. It really depends on the requirements that will allow us to take advantage of the 3GPP release 17's, the standards around URLLC and TSN, such that we can deliver value to the customer. So again, we will be very guided by the customer requirements to take advantage of the REL 17 specifications. And completely agree that 5G is not enough, right? If it's just 5G, it would just be only smart edge with the RAN and the core. That's not, when we bring together these disparate workloads, there's huge dependency on the ability, as Walter mentioned, our edge insights for AMR, in order to do this localization, depth sensing, navigation, traffic mapping, all of that, in addition to the AI and computer vision capabilities, like the video recognition, all of that. We really had to bring these workloads together, converge these workloads together for it to really work for this particular use case. So completely agree that you need way more than 5G. 5G is not enough.
Yeah, that's fascinating.
Daniel, if I can add one more point, because we're talking about the factories or manufacturing, and so far we talk about logistics centers, and I just want to make sure that we understand that we also look on the factory of the future. And we have history automotive, and a lot of those automotive factories are moving away from fixed assembly lines to flexible production line, and they will be using AMRs to fetch and carry and just-in-time delivery of parts. And every manufacturer this, and every manufacturer company has a warehouse. So it's very similar process like doing the warehouse automation, but it's more simpler because it's less dynamic. So I want to make sure that we also talk about manufacturing.
That's absolutely great. I wonder if I could, we got 1 minute left. Walter, just maybe last one for you. This is really exciting collaboration. You want to look to the future. If you could talk to us about any deployments you've got very briefly, how that's going.
Yeah, we are preparing for trials in both US and Europe, and including automotive. And we are very excited to be part of this automotive revolution. We're going to have a number of press releases in the future. Right now, the focus was on designing the product, building the product, and really working with the partners, starting the trials in both US and Europe.
That's great, and I think that just about gets us out within time. So I'd like to thank both my panelists very much. It's been an absolutely fascinating discussion. Thank you very much, Renu. Thank you very much, Walter.
Thank you.
Thank you very much, everyone, for listening for those questions. It's been a great discussion.
Thank you all.
A good rest of your day. Bye.